Have you ever asked, how am I going to connect my data center to the cloud? How am I going to access that important data in the cloud? Or how am I going to transfer my database information to a cloud resource? And how I'm going to handle all that overlapping IP addressing? Then this video is for you. Stay tuned as I show you how you create an IPSEC VPN tunnel from your data center to the cloud, and how I show you how to handle overlapping IP addresses between the two. My name is Mark Snyder, and thank you very much for watching this video. Let's begin with this simple design as a reference point. On the left-hand side, we're going to emulate a data center, and on the right-hand side, we're going to emulate a cloud resource, which would be our remote data center. This could also be thought of as a multi-cloud experience where you have two different cloud vendors that you need to create a VPN between. No matter if it's a multi-cloud VPN or a remote data center, the concept still remains the same in that we're transferring data securely between the two locations. Now let's expand off that simple design into something a little bit more realistic. On the left-hand side, I'm representing an on-prem data center, the West Coast, called California. On the right-hand side, I'm emulating a cloud data center called Virginia that's on the East Coast. Now, as part of this demonstration, you'll notice that both sides are exactly the same. And this is the same virtual SRX and the same two hosts that represent the data center servers. Now let's look at the details of each data center. We have two hosts that emulate servers, each host being on its own routed subnet, and with each subnet connected to its own zone on the SRX Firewall, and each zone being the trusted west and east zones. In the center, we have the SRX Firewall that is firewalling each of the zones, which includes the untrusted internet-facing zone. We also have an edge gateway. Since we're pretending that this is an on-prem data center, this might be an edge router, with this edge router also translating from private addresses to public addresses, and connecting with our public untrusted interface, creating a secure VPN to the other data center. For the rest of the conversation, we will need to pay special attention to our location, which on the left-hand side is California, or the West Coast, and also the East and West zones, as this will become important when we're doing a demo and sending traffic between the two locations. So I'll have California with a West and East network and Virginia with a West and East network as well. One representing the West Coast on-prem data center and the other representing the East Coast cloud data center. On the East Coast, we're representing the cloud infrastructure. And as I mentioned earlier, this data center is an exact mirror replica of the on-prem data center, including the same IP addresses that introduces a common problem. To add to this challenge, each host at each of the data centers has web servers that need to be accessible from the internet, in addition to being able to access the internet locally. Let's review what we're going to accomplish here. We're going to set up a VPN tunnel between the two data centers so we can transfer data. We're going to ensure that that tunnel is encrypted and secure. We have to provide security between each of the zones and between each of the locations. We have to translate the addresses because both of the data center servers have the same exact IP addresses. We need to allow those hosts to be able to access the internet at their local internet access points. And we have to allow for web server and SSH access to each of those servers from the internet. All right, let's get building. I created a script just to deploy two CloudFormation templates. One CloudFormation template is in the AWS West California region, and that's our on-prem data center. And the other CloudFormation template is the data center side that's on the East Coast out of Virginia. And here you can see I'm just launching those two scripts where I'm specifying the regions, and I have the CloudFormation templates. I will have those CloudFormation templates on my GitHub page, so when you would like to mimic this setup, you can download them there and deploy it just like I showed here. I opened up a browser and I logged into the console in AWS, and I've navigated to the CloudFormation page, and you can see where I deployed the CloudFormation template in California. And I try to keep the same color theme as I did in the previous drawing. Now let's migrate over to the Virginia side as well. On the Virginia side, it's the same exact template that we used on the California side. Now with having the two different color browsers, I'm hoping to avoid some confusion as I'm pulling keys or I'm navigating to the different data centers. Now while we're in Virginia, one of the things is that when we attach interfaces to the SRX, it doesn't auto, the interfaces aren't ad hoc. So we have to reboot the SRX for it to identify those additional interfaces. So I'm just going to open up a couple more tabs in each of the sections here. All right, we see that the instances that are running, and we are going to take a look here and adjust this a little bit. So the SRX, okay, and we're going to reboot this instance. All right, and then we're going to also go back in on the West Coast side and do the same thing. And this should take about 3 minutes, and we'll come right back. While we're here in California, we're going to grab a few things of information. So we're going to travel to look at the networking portion, and we want to grab these two IP addresses. Now, if we look at this, one side, all right, will be the FXP0 for the management address, so we can take a look at the configurations there. And the other side will be the untrusted zone, and we want the public address here so we can point the VPN at it. Now, the other thing I'm going to do while I'm here is when I use my CloudFormation template, I create my keys and I actually store it in the Systems Manager perimeter store. Now, you don't have to do that. It's just something that I do. It makes it easy when I'm doing demos. I copy this key and I'm going to put it in a local file. And I'm going to call this key Cali. Now we need to do the same thing on the Virginia side. That includes the public addresses for the management interface and the untrusted interface, in addition to the security keys. All right, logging into each of the SRXs, and you'll see here when I log in is that the name of the SRX has already been changed, and that's because in my CloudFormation template in the user data field, I pre-populated the SRX's configurations. So on boot, it has all the configurations that we'll need with just some minor configuration. All right, now that we're logged into the SRX, let's go into configuration mode and check out a couple of settings for IPSEC and IKE. The first thing that we want to do is we want to change the remote peer address of the IKE gateway for the IPSEC VPN tunnel. When we deployed the template, we just put an address in there just to for a placeholder, but now we need to put in the destination address, which is the public-facing address of the external remote gateway. The first thing we're going to do is delete the existing gateway and then add the new gateway. Before we commit this to the configuration, let's take a look at the existing IKE tunnel and IPSEC tunnel associations. The first thing we're going to show is that if there's any active IKE communications between the two hosts. And we're going to do that by showing what the active peers are and also any security associations that are existing. Now, as you can see that there is no active peers and there's no security associations. We're also going to take a look at the inactive tunnels. And we'll see here the old configuration, or at least the old connection to the old tunnel that was in the configuration. So this is the address that we're going to change to the new gateway. And we'll also see that there's no security, there's no IPSEC security associations because the tunnel is not up. Now let's add the new gateway information and commit those changes. Now let's go to the AWS dashboard for California, and we're going to grab the public address for the California gateway. This way we're going to add that to the Virginia side as the remote peer for Virginia. And we want to ensure that we're grabbing the public untrusted interface of the SRX and not the public management address of FXP0. Now let's do the same thing for the California side, ensuring that we're grabbing the Virginia untrusted public-facing address to enter as the peer in California. Now that we have both those peers defined, let's commit that to the configuration. Now with our configuration set, let's look at our IKE configurations, our security associations, and our inactive or our active peers. And we'll see that nothing has changed because when we configured our VPN, we only set up our tunnels to associate based on traffic. So if we look at our IPSEC inactive tunnels, we'll see that it's waiting for a trigger. Now, if we set this to immediate, then that tunnel would come up immediately. And if we look on the California side, we'll see the same status waiting for traffic to go across the tunnel. All right, let's SSH into each of these hosts. And just a reminder that I port forwarded or destination NAT. Now, this could have been done with a static NAT, but because of the dynamic interface on the SRX on the external port, I chose to use just a destination NAT to use this translation. I'm going to change the host name to something that's a little bit more friendly. I'm going to move this window to over here. And I'm going to log into all the other hosts and change their names appropriately to identify them as California, East and West, and Virginia, East and West. Now with our hosts renamed and so they're easily identifiable, we're going to go and set up a couple of watch triggers on the SRX so we can determine when the tunnel comes up. Before we kick off the VPN tunnel, let me review the NAT table that we set up here. As I was discussing in the beginning, Each host has overlapping addresses from either California and Virginia. So for example, on the West Coast, the host address is 10.2 and 10.3, 0.10, and it's the same thing on the East Coast. So with some fancy static NAT translation, what I've done here is on the east side, or I should say in Virginia, the California host looks like 192.168.3.11 for the west address and .12 for the east address. And then on the California side, the Virginia host looks like 192.168.3.1 for the west host and 3.22 for the east host. To establish a tunnel, we're going to ping from the Cali west host to the Virginia west host. And we can see immediately that there's a change in the tunnel status. So now if we look at the IPSEC Security Association, we will see that there's a VPN tunnel set up between the two SRXs. From here, we can see that the IKE tunnel that was created is type ESP, and that the authentication, or I should say the encryption used in the VPN tunnel is AES CBC 256, and then using authentication, the hash is a SHA-256. And then by viewing the IPsec statistics, we can see the encrypted and decrypted packets created by the ping. Okay, let's look a little deeper on the IKE and IPsec tunnel creations in the configuration. And we can do that through a show, configuration, security, IKE. And let's do this for the other side. Okay. For the IKE portion, we're going to need 3 sections: the proposal, policy, and gateway sections. The IKE proposal section defines on how IKE is going to negotiate the security associations. This is the security associations between the two SRX and needed to establish the IPsec tunnel. The proposal specifies what type of encryption algorithm we're going to use, what type of integrity, and also the Diffie-Hellman group that we used to protect the credentials of IKE. In this example, I'm using pre-shared keys for my IKE authentication. And as part of authenticating that key, I'm using a SHA-256 cryptographic security hash. That hash ensures that the key that's being sent is the same exact key that's being stored in to be accepted by the destination. If we did not want to use pre-shared keys, we could easily have substituted digital certificates instead of the keys. In the policy section, you could have multiple policies. For example, let's say you had one location that had a different set of security needs versus a separate location. So one site maybe uses digital certificates, the other site uses pre-shared keys, or maybe even AES encryption versus DES encryption. What you would do is you'd have separate policies, and you would refer to each of those policies when you're creating an IKE session for each of those locations. You can also have several gateways defined. In this example, I called the gateway remote. And also in this example, for that gateway called remote, I would also refer to a policy used for that specific gateway. In this example, the policy that happens to be used is called IKE policy. We would also need to identify what our peering address is, that is the other end of the tunnel that we're trying to establish. In this example, you can see that the 3.2230 address is referring to the East Coast or Virginia, and the opposite of the address 54 is referring to the California address. In this example, I used a local and remote ID, and if you were to look through the IKE negotiation, it actually checks to see if the remote ID matches what is expected during the negotiations. We also need to identify where the end of the IKE tunnel is going to exist. In this example, we are terminating the tunnel on the outside untrusted interface, which is a physical, or I should say a virtual interface 1 with a logical ID of 0. For this example, we are using IKE version 2. If you have requirements where you need to adjust the IKE phase 1 as either main mode or aggressive mode, you'll have to use IKE version 1 and then set your modes here. There are benefits of using IKE 2 over version 1. Some of those benefits are it requires less bandwidth for the communication, it offers rekeying of security associations, it also has some detection for if an IPSEC tunnel is down or not. All right, so now let's take a look at our IPSEC configuration. Here we also have 3 sections: proposal section, a policy section, and the type of VPN section. Like the multiple sections in IKE, you can also have multiple sections in the IPSEC sections. In this proposal section called the IPSEC proposal, where we have the protocol and authentication and encryption setting. Protocol types can typically be authentication header, AH, or ESP, which is an encapsulated security payload. Now, AH can offer integrity protection in making sure that the packet arrives in a correct format. However, AH does not offer any type of encryption. So we're going to use ESP because it offers integrity, also data origin authentication, in addition to encryption and also anti-replay services. Now we can see here that we're using HMAC SHA-256. Now, HMAC SHA and SHA-256 are both forms of cryptographic hash functions. However, the difference being that SHA-256 is a one-way hash algorithm that is used to compare the results of the key that is stored to the key that was received for IKE authentication, whereas HMAC SHA-256 is used for authentication and integrity of the message within the VPN tunnel. And lastly, we see the encryption of the message for the tunnel as AES-256. We can also have different policies, just like with IKE. In the different policies could be associated for different tunnels. So for example, if we have a different tunnel where we want to use DES encryption or perhaps maybe a different type of authentication, we could refer to that policy when we refer to the VPN tunnel itself. In this last section, the VPN section, I have a VPN called VPC. Now here I'm binding the VPN to a virtual interface ST0 with a logical interface of 0. Now this is important because I could have several VPNs, each terminated on different logical interfaces. And probably even more important is I can assign those interfaces to security zones. For that VPN tunnel, I point it to the IKE gateway remote, and at the same time I associate the IPSEC policy called the IPSEC policy. Now, established tunnels on traffic only sets up the VPN tunnel to transmit traffic only when it sees interesting traffic. So when I use the ping and I ping the resource on the opposite side, only at that point it brought up the tunnel. So this might be useful on a connection where you're being charged for throughput. If you're not, then you could also set the established tunnel to immediate. So let's look at a couple of other settings that are required for setting up the VPN between the two SRXs. The first thing that we're going to need to do is to allow IKE to be able to establish a session to the interface where the VPN is terminated. So in our setup, we have to allow for IKE as a system service on that security zone, and our security zone name is VPN. And then you see that we attach the ST0 logical interface 0 interface to that zone.
And because the security VPN is associated to a security zone called VPN, we also have to allow that zone traffic to and from the other trusted zones. So here I'm showing that I'm allowing all traffic from the VPN zone to the trusted east zone that's in California with a source address of any, a destination of address of any, an application any, and I'm permitting it. Now, likewise, I have to do the reverse so I can allow traffic from the east zone in California out to the VPN to get to Virginia. And we have to do the same thing in the Virginia side to allow traffic to and from California. In addition to our requirements, we're going to allow each of the hosts to be able to access the internet, and that would require some sort of source NAT translation to be translated into a public address. Additionally, was to expose the internal web servers out to the public internet. And that we're going to do with destination NAT translation. With our terminal session set up here, now we're going to do a trace route from each of the hosts to show that internet connectivity in each path. So let's do a trace route. Oops. I'm going to set the hops to 2, and we'll just ping here. Well, copy and paste. All right, and we can see from the west, on the California West host, is that it's hitting the .4 interface of the SRX, and on the east host it's hitting .2, and likewise on this side it's hitting 4.147 and 3.104. And if we ping on the same host, we'll see that we have outbound connectivity. Okay, and then we're going to look at the NAT translation tables. Right. And we see from the inside interfaces to the outside, and our translation hits. I'll show the other side. And likewise. And if we go back and we look at the California side, and what happened here? Let's look at the SRX, and we'll see the security interfaces here, or I should say the interfaces on the SRX. Right, and we'll see that the east and west hosts tie into those addresses, 3224 and 4168 for the trace route. And if we look at the Virginia location, and we look at the same, and we'll see that those addresses 3104 and 147 that align with our trace route. Now, as part of the user data for each of the hosts, I also have a script in here on each host that the script is actually created during the deployment as part of the CloudFormation template. It just downloads in Apache Web Server and then sets up a template that's pulled from my GitHub page. So let's kick this off. And of course that's not going to work. Let's see. There we go. All right, and since we have a VPN tunnel between the two, we should be able to pick up the script arbitrarily from any of the other hosts. So we'll do it, wget from, let's say, 192.168.3.12, which, 3.12, which the 12 should be the east host of California. And we can see that we did get that index page. Okay, let's open up a web browser and navigate to that Apache web server. We will need the outside public interface address of the SRX. And we'll open up a new window here. All right, HTTP : right, and we're redirecting that address to 8003 for the west side. Oops. Now HTTPS. There we go. So that's the west host, and we can see that with the 10.3 address here. Also, AWS AMIs append the region name to the host name during its boot, so we can see that this is in the west region. Now we'll see west on the east host, on the east web server, but that's because it's in the west region. And here you see that 10.2.0.10 host on the west region. So now let's go over to Virginia. Now we're going to do the same thing here. Now here we have the EC2 address for the East Coast. All right, and now we'll go to the West server. And here we see 2.10. Okay, let's review what we accomplished here. We set up a VPN between two data centers. We ensured that that tunnel was encrypted and secured. We set security zones between the two locations of the East and West data center, in addition to creating security zones within each data center. We allowed for overlapping IP addresses of hosts within each data center. We allowed the host to access the internet with a translated public address. We allowed the hosted web servers to be accessible from the internet in addition to SSH connectivity. If you would like to replicate what I built here, stop by my GitHub page at Enter the Void. Here you will find CloudFormation templates that I used to create this sample network, along with the network diagrams and the NAT translation tables. My name is Mark Snyder, and thank you very much for watching this video.